I want to take the derivative of the absolute value of x. In order to do this, I'm going to rewrite the absolute value of x as a square root of x squared. Then, I'm going to rewrite the square root of x squared as x squared raised to the 1/2 power. Here I'm going to use a chain rule. So I'm going to bring down the exponent. So let's first identify the outside function as the 1/2. So that's the root. So bring down the exponent. Keep the inside the same. Subtract 1 in the exponent. And then take the derivative of the inside. So the inside meaning x squared. Okay, so now let's simplify. We have a 2 here that cancels. I have x at the top. And here there's a negative exponent. So I could just put that in the bottom and make it positive. And I have x squared to the 1/2 power. That's the same thing as doing the square root of x squared. From above, we said that the absolute value of x is equal to the square root of x squared. So we can replace that with the absolute value of x. So that is our final answer. So what we showed is that the derivative of the absolute value of x is equal to x over the absolute value of x. Okay, next let's look at x equals 0. What is the derivative of absolute value of x at x equals 0? I want to use the alternate definition of derivative. So the one I'm looking for is the limit as x approaches c of f of x minus f of c over x minus c, where f of x is the absolute value of x and c is 0. Okay, so derivative of absolute value of x at x equals 0. So let's plug that in here. F of x is absolute value of x, and f of 0 will just be 0 over x minus 0. This is the same thing as absolute value of x over x. Absolute values are a little tricky when you're taking the limits. So you want to be looking at the left hand and the right hand limit, because the way the absolute value of x is defined is it's negative x when x is less than 0, and x if x is greater than or equal to 0. So now, whenever we're looking at 0 from the left, it makes sense that we're going to be looking at this one. Okay, so that would just be negative x over x. And if we're looking at 0 from the right, it's obviously going to be this one. So that's x over x. So this limit is going to be negative 1. The bottom limit is going to be positive 1. One thing to notice is the left hand and the right hand limits do not equal each other. So the derivative at x equals 0 does not exist. And that's obvious because the derivative is x over absolute value of x. And when I plug in 0, I'm really dividing by 0. You can't do that. So the derivative there does not exist. Next, we're going to be doing some derivatives. So let's actually find the derivatives of absolute value of x functions. So let's say we have x, the absolute value of x squared plus 2x. And I want to take the derivative of that thing. One thing to notice is the exponent of the absolute value here is 1. So it turns out whenever you take the derivative of odd exponents for absolute values, it's a lot more work. Let's just say hypothetically if I had an even exponent. So let's say if I had it squared, this can be rewritten as x squared plus 2x quantity squared. So the absolute value disappears, and I could just disregard it and continue just like a regular chain rule problem. But unfortunately here we have 1 as the exponent, so we have to do some more work. Recall that the derivative of the absolute value of x is x over absolute value of x. In this case, we're going to replace x with whatever's inside. And the chain rule says take the derivative of the inside. So x squared plus 2x. So we have to be very careful here. Notice I did parentheses. I did not do absolute value. So the only case when you do the absolute value is whenever you have an exponent bigger than 2. Let's say 3. That case, the inside is the absolute value and the outside is the cube. Okay, here in this example, the outside is the absolute value and inside is the x squared plus 2x. Okay. So that's that. All right, now let's replace that. So x we said is x squared plus 2x all over absolute value of x squared plus 2x, and then times the derivative of x squared plus 2x is 2x plus 2. We can do some simplifying here. So notice we can pull out an x for this one, and we can pull out a 2. So we'll just move the 2 out in front, and then we're going to pull out an x. So we have x plus 2, and then times x plus 1. And the denominator, we're going to leave it alone. So we're going to leave it as x squared plus 2x. Okay. So you may be tempted to factor it out. So you may say, okay, well, that's just x over x plus 2. And then, you have your 2x, x plus 2, and x plus 1. And say, okay, well, I can cancel out the x's and the x plus 2, so I'm just left with 2 times x plus 1. And this is wrong. And the reason it's wrong is because we have odd exponents. X over absolute value of x does not equal 1. Turns out it equals 1 if x is greater than 0 and negative 1 when x is less than 0. So we don't know what x here is exactly. So we're just doing a general derivative. So you can't just cancel it. And same thing goes with x plus 2. You can't cancel it. It does not equal 1. It sometimes equals 1, but not all the time. So this is completely wrong, and we are finished. This is a derivative. Okay, let's look at another example. Let's say we have absolute value of x times sine of x all cubed. Okay. So this one is a product rule and a chain rule problem, and it's a bit complicated, so let's be very careful here. Let's identify what the inside and outside function is. The outside function will be the cubed, so let me just write that out. Outside is x cubed. Inside is the whole absolute value. Okay, so it's not just x sine of x, it's absolute value of x sine of x. Okay, so that whole inside is being cubed. So the absolute value is being cubed. Okay, so let's recall the derivative of the absolute value of x is x over absolute value of x. Okay, so let's keep that in mind. But first, we have to do chain rule. We have to bring down the exponent, keep the inside the same, subtract 1 in the exponent, and then take the derivative of the inside. So inside we said is absolute value of x, sine of x. Okay, so that's going to be the same, x sine of x squared. And really, because we're squaring it, we're going to leave it alone, actually. We're not going to cancel out the absolute value. So let's just leave it as it is. And then we're going to take the derivative of x sine of x. So absolute value of that. So I'm going to replace x sine of x with x with x sine of x here, and then take the derivative of x sine of x. So first step, we replace x with x sine of x. Okay. And now I'll take the derivative of x sine of x. So the derivative of x sine of x, we have to use the product rule. So the derivative of x is 1 times sine of x plus the derivative of sine of x is cosine of x times x. So I'll just put it in front. Okay, so that's just going to go over here. Okay, and now notice that that's going to cancel. So that's the 2 becomes a 1, and then the absolute value of x sine of x goes away. So finally we say 3 times absolute value x sine of x times x sine of x. So here this x sine of x is not in the absolute value. Okay, times sine of x plus x cosine of x. And that is my derivative.